Hello students, today we will study the question number 6 of exercise 6.2. This is the topic of standard 10 chapter number 6 triangles. What is the question? Question is, here we have given one of the figure in which there is a triangle and we have said that ABC are the points on OP, OQ and OR respectively. So that AB is parallel to PQ and AC is parallel to PR. So that BC is parallel to QR. So here we have given one of the triangle, that is ABC. O is the point inside of the triangle ABC. Now when we extend OA, there is a point P. Extend OB, there is a point, we get the Q, and by extending OC, we get the point R. And when we join this, we get the another triangle PQR. So in short, here two triangles are there, triangle ABC and triangle PQR. What is the condition we have given here is AB side is parallel to PQ and this AC is parallel to PR. And now we have to prove that BC is parallel to QR. This side, third of the first triangle, is parallel to the third side of the another triangle. That we have to prove. So here, now we have to consider this triangle OPQ, right? So when we consider the in triangle OPQ, in triangle OPQ. Now we consider this triangle OPQ. Here we know that AB is parallel to PQ, that we have given. AB is parallel to PQ, and therefore here we can write down that OA upon AP is equals to OB upon BQ. OB upon BQ. Give it the equation number 1. How we can write down? We can write down here is according to the theorem 6.1 or according to the basic proportionality theorem. Right? Okay. In the same way, now consider this triangle OPR. So, in triangle OPR, here we have given that AC is parallel to PR. AC is parallel to PR. So, here also we can write down that OA upon OP, OA upon AP is equals to OC upon OR, OC upon CR. Okay, this give it equation number 2. Here also this is we can write down according to the theorem 6.1. Now, when we compare these two equations, equation number 1 and 2, here we can see that left hand side there is OA upon AP, here also OA upon AP. Obviously the right hand side parts will be equal. So, when we compare equation number 1 and equation number 2, what we get? OB upon OQ, OB upon BQ will be equal to OC upon CR, OC upon CR. OB upon BQ is equals to OC upon CR. Now see, this thing is lead us to say that according to the theorem 6.2, in the triangle OQR, right? Here we can write down that in triangle OQR, OB upon OQ is equals to OC upon CR. That means what is the line BC that makes the two sides of this triangle into the divides the two sides of the triangle into the same proportion, right? So in triangle PQR, and here give it equation number 3. In triangle PQR, from equation number 3 and according to the theorem 6.2, consider this triangle OQR. From equation number 3, here we prove that, here we get that OB upon BQ is equals to OC upon CR. So according to the theorem 6.2, we can say that BC is parallel to QR. Right? The line which divides the two sides into the same proportion is parallel to the third side. That is the theorem 6.2. And according to that, we can prove this result. That is the required result. We have to prove BC is parallel to QR. Okay. So in this way, now you can think this type of sum and you can solve using the theorem 6.1 and 6.2. Okay. Now let us study the question number 7. What is the question? Question is, using theorem 6.1, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Okay. Here we have given in the bracket, recall that you have proved it in class 9. Yes, we have proved this thing in class 9. But here we have to prove this using the theorem 6.1. So here, let us take let a triangle PQR, right? And S is the midpoint. S is the midpoint of one of the side PQ, right? Let us take S is the midpoint of one of the side of the PQ, and ST is passing through PR, right, and intersect PR at point T, right? So here we have given that S is the midpoint of one of the side of the PQ. So we can write down that PS is equals to SQ, right? That we now know that we have given. What we have to prove here is, we have to prove that PT is equals to TR. PT is equals to TR. That means we have to prove that T is the midpoint of this side PR. So now let us first of all again understand the question. We have given that there is a triangle that we have taken as a PQR. One is the point on one of the side that we have taken, it is S. If a line pass through this point and parallel to QR, yes, here we have mentioned one thing, that is ST is parallel to QR. That we have given, that the line pass through the midpoint of one side of a triangle bisect the third side. So this bisect the third side, that means PT is equals to TR. That must be happen here, and that we have to prove. Okay, so here we can say that in triangle PQR, ST is parallel to QR, so that according to the theorem 6.1, we can say that we can write down that PS upon SQ is equals to PT upon TR, right? Give it the equation number 1, and according to the theorem 6.1, this is the sides which are in the proportion. Now here we have given that ST, we have given that PS and SQ are the equal. These two sides are equal because S is the midpoint of PQ. So PS and SQ are equal. That means PS is 5 cm, SQ is also 5 cm. PS is 10, SQ is also 10. So we can cut out it. Both the values are equal. So from the numerator and denominator, we can cut out. What we get here is 1 is equals to PT upon TR. By take this PT to the left hand side, we get PT is equals to TR. Both the values are equal. And what is the meaning of this? PT and TR, they are also making the equal parts. And that means T will be the midpoint of the side PR. But here we have to prove that PT is equals to TF. So right. So this is the result that we have already proved in standard 9. Here also we can prove this theorem, this result using the theorem 6.1. Okay. So this is all about this lecture. Thank you.